It was just this perfect balance of like, okay, manageable enough to like write tooling for it, but realistic enough that you could actually build stuff with it. Projects that I've worked on, even now, like multiple years later, I've still targeted Elm. So yeah, from a researcher's perspective, it's like lovely from that regard.
Hey folks, welcome back to Elm Town. I'm your host, Jared M. Smith. We'll be visiting with Justin Lubin today. But first, let's talk about our sponsor, Logistically. At Logistically, we make intuitive software to help logistics teams make better decisions and improve efficiency. We build the front end for all new features in Elm. If you're interested in our mission and enjoy writing Elm, please drop us a line, elmtown@logisticallyinc.com. Now, I'm going to introduce Justin Lubin. Justin is a PhD student researcher at UC Berkeley working with Sarah Chasins. He has worked with Ravi Chugh at University of Chicago on Sketch and Sketch, a direct manipulation programming system for creating HTML and SVG documents. He has done research on how statically typed functional programmers write code, including Elm users. He loves, quote, programming languages, human-computer interaction, biology, social justice, music, art, and math, and is happy to grow this list, end quote. Justin, welcome to Elm Town.
Thanks so much. It's really an honor to be here. I appreciate it.
Just to set the scene a little bit here, I'm starting this series of episodes about the process of learning Elm and teaching Elm. And so I think this will be a great place here where we can pick Justin's brain and learn a little bit about the research that he's done in these areas. So to get started with that, I wanted to ask you, why did you decide to become an academic researcher on programming languages and human-computer interaction? It's your sort of origin story.
Origin story. Awesome. So I guess it started back when I was first learning about like statically typed functional programming. I saw this language that was being referred to online a lot called Haskell. And I was like, ooh, like, what's that? Like, I want to see what that is. And I like looked at the website and I was like, I'm not sure I like this. It looks so weird. Like, what do you mean there's like no variables or like no mutation or like anything like that? I'm like, no, this is not for me. But like people kept talking about it like so like, in such high regard. So, I looked at it again and I was like, okay, maybe there's something here. And like, eventually I started to like really get into it. And I was like, oh, actually, this is really cool. So I was really excited by like programming languages and like the theory behind it and like, starting to like dabble in the sort of like category theory stuff. And I was thinking like, gosh, this was maybe like towards the end of high school. And then when I wanted to go to college, I was like, maybe I want to start like talking to a professor who like does this kind of thing. So I reached out to Ravi Chugh, University of Chicago, and because he was doing the Sketch and Sketch project. And initially I was like coming at it from this sort of like, really keen interest in like, maybe behind the scenes a little bit of like how the programming languages work. I also really like math at this time, still like math. I was just sort of like really excited about that. But then like over time, like as I was working on Sketch and Sketch, which as you mentioned before is this programming tool where you can essentially do sort of Illustrator or Photoshop like operations on like the output of like a program. So, maybe drawing like a rectangle or like a circle or aligning things. And as you're working on that, it will actually construct a program for you in a language actually very similar to Elm. So you can do things like, maybe make a Ferris wheel and it has like 5 spokes in the Ferris wheel, but then you realize actually you wanted a 6th one. And so like in Illustrator, you'd have to like redraw the whole thing, compute the angles, like 360 degrees divided by 6, something like that. But in this case, because you have a program, you can actually just change the 5 to a 6. And so this really got me thinking about like, gosh, there's this whole like world of, really interesting programming language theory, how programming is working behind the scenes, like the idea of like program synthesis, which is like generating programs, sort of like in this situation where we're like, building a program based off of the users, like drawing rectangles and whatnot. And you can take all of that really awesome, interesting mathematical stuff and actually, work with people, build tools that are going to be like really interesting and useful for them. And that's a sort of, where this kind of human-computer interaction idea sort of came into play. So yeah, over time I got, super interested in the human-computer interaction side of it as well. And I kind of just had a really amazing time doing this sort of like working on Sketch and Sketch, doing some research with Ravi. And so I just decided to stick with it. And yeah, doing similar sorts of stuff now, continuing in grad school, working with Sarah Chasins. So yeah, it's just been a really good time for me.
Okay, cool. Well, let's go back. So you mentioned Haskell at the beginning of this, and that's what sort of started this whole trajectory. But it sounded like you had some programming experience already when you were talking about, because you said like you didn't see any variables and, just how it was different. So what kind of experience did you have before that?
The very first exposure that I had to programming, I was actually really interested in graphic design. Maybe that came back with Sketch and Sketch too, but I was really interested in like Flash animations, when that was a big thing. I was like, oh, like I want to make like a Flash animation. I want to make like a game in Flash. And so I was like, okay, how do I do that? Like I had a technology teacher, I think like in middle school, like not programming or anything, just like, how to use Microsoft Word. And he was like, oh, like I think you have to like do some programming or something like that. So I remember I went to like the public library in my town where I was growing up, and I like just checked out a bunch of books on like ActionScript 3 for like, Flash. And I had no idea really what like any of it was like doing, but it was like super, super fun. And from there, I got like really interested in like JavaScript, making some like, games like in JavaScript or like, different like, I don't know, utilities, whatever. And so I really came at it, I guess, from the sort of like JavaScript, ActionScript kind of language originally. And then eventually, like in high school, there was like a Java course. So I was like learning that and Python and those sorts of things as well.
Okay, cool. And then at some point you discovered Haskell, like you said, and that got you interested in the theory behind it, category theory, things like that. And then I guess you were researching for college, and that's when you found Sketch and Sketch. Is that correct?
Yes.
Okay.
Yeah. So I just reached out to a professor that was at my university. There was like a couple of professors who were like doing programming languages stuff, and the stuff that Ravi was working on really sort of spoke to me. So I kind of just reached out to him to chat about it. And then eventually the chat sort of evolved into like, oh, like, maybe I can actually help out. And then like I was really getting involved, and I worked with him for like 4 years. And that was pretty much, I think, exclusively, except, yeah, maybe one of the projects was OCaml, but like all of that was in Elm, which is really delightful.
Okay. So yeah, let's dive into this a little bit. So Sketch and Sketch, you said, what part of it is in Elm? Because I know it's like an Elm-like language that you use, but... Yeah,
it's actually all written in Elm, and there's a language inside of Sketch and Sketch that is like Elm that you can use too. It's like, there's a parser and like an interpreter and everything like that written in Elm for Sketch and Sketch for a language like Elm. So it's kind of like Elm all the way down.
Yeah, you took the words from my mouth. Yeah. Okay, so Elm all the way down. And so this parser and compiler, this was written like differently outside of the Elm parser and compiler, right? So these were...
Yep.
Okay.
It's totally separate. Initially, actually, the language that we used was more like a Lisp-like language for the sort of syntax. But then we rewrote that to be more Elm-like just because I think we preferred that. And yeah, completely sort of separate from any like existing tool, like, Elm format or the compiler or anything like that. Yeah. Consequently, we don't really have very good error messages because it's kind of just like a prototype, but yeah.
Oh, okay. Interesting. So yeah, a little bit more about Sketch and Sketch. And this is more, let's kind of talk a bit about the concept and what this is. Looking at it from maybe the perspective of what it's not. So how does Sketch and Sketch differ from other visual coding tools like Visual Studio, Delphi, and Hazel?
Yeah, totally. So I think that a really interesting aspect of Sketch and Sketch is that we kind of wanted to push the limit of like what would be possible of being able to construct a program without actually typing any code whatsoever. So, you mentioned the Hazel project, and that's actually like one of my favorite projects ever. I love Hazel. Cyrus is super awesome. Huge shout out there. I think that, the sort of perspective on that project is that they kind of want to like revolutionize and like modernize what it actually means to like write code. And so they have this idea of a structure editor where every single like sort of state, like as you're typing, whatever your editor state is, it's going to have some sort of meaning. So you can like run the program even if it's incomplete. You can get type information even if it's incomplete. They're doing things about like, sort of localizing type errors now, and like, new sorts of ways of like doing type-based stuff. Which is like super awesome. In contrast, I would say that like Sketch and Sketch is more about like, okay, if we're sort of, committed to, not necessarily textual edits, but something like graphical edits. We want to see like, how far can we push just using graphical edits to construct a program? That's kind of like more the direction that like Sketch and Sketch would take. So for example, the sort of lead PhD student, so I was like an undergrad when I was working on this, is Brian Hempel. And one of the big projects like in his PhD thesis was basically like getting Sketch and Sketch to the point where you can actually like construct fully recursive programs, essentially things that are like looping, like building like a fractal, sort of using just manipulations on the output itself. So you can write, just sort of like code that you would normally have to write, like using like a keyboard and like, text editor and everything, solely using sort of graphical manipulations. And so I'd say that that's kind of like the difference maybe between like the work on like structure editing, which is like separately very cool and like would also be like super awesome to like slot into Sketch, for example. And something like Sketch and Sketch, which is more like output directed, I think is like the word that we use to describe it.
Great. Yeah. Thank you for making that distinction. I think that makes sense. So I have a couple of questions here from your PhD lab mate, Parker Ziegler.
Okay.
And there's two separate lines of questioning. So I'll start with this first set here. It is, quote, can you chat about your experience working on Sketch and Sketch while in Ravi Chugh's lab at the University of Chicago and how Elm informed the direction of that project? What was it like getting going with Elm in a multi-thousand line code base?
It's a good question. So going into the project, I actually didn't know Elm whatsoever. So, I did know Haskell, and I was like really excited about it. I wasn't like a super advanced user of Haskell, but like, I enjoyed like, monads and like things like that. And so like I went to Ravi and he told me it was like an Elm, and I was like, okay, I guess like, I can learn this, because I was like really interested in like working on the project. And I just remember I pulled up the sort of like, I think I was like on my phone, like getting food somewhere or something like that. And I just remember I was like looking at the official like Elm book, and it was like so readable. I was just like, wow, like I can just like read this like right now as I'm like eating food. And it was just like really sort of like easy onboarding. I did have like, experience doing like functional programming in the past. But like, it just felt like, unlike, maybe some other languages in the past, it just felt like a very sort of like easy sort of onboarding experience for me. And then in terms of the code base, it was definitely like a challenge, especially as someone who had never worked in a large code base before. Like I only ever just done small projects by myself, to sort of dive into something that was, multiple thousands of lines of code in a language that I hadn't really used before. But I think, I definitely credit Ravi here. He gave me like really small projects to start out, stuff that was like very well constrained, not necessarily like research, per se, but like just getting me familiar with like, lots of code and how to use Elm and sort of like working up there. So I definitely credit like mentorship to being able to do something like that, in addition to just like how nice Elm is.
Let me ask you about kind of going back to Sketch and Sketch here and that work. What was kind of the result of that work? Like, were there findings where you thought that, okay, this will be a challenge that we're not sure if it's possible to overcome, or what, like, where did it end for you?
Yeah, that's a great question. So I would say that, I don't know, in my mind, I sort of think of it as like the Sketch and Sketch cinematic universe. There's a lot of sort of like related projects, sort of like different like lines of inquiry, which is maybe like sort of how like an academic kind of project goes. There's not necessarily like a product that's at the end of it, but it's kind of like, okay, what did we learn? Exactly like you were asking. And so one of the things was just this really cool, push of like, okay, let's not necessarily consider whether we should be constructing recursive programs, completely graphically. Let's see, like, can we even do that? And sort of just like really pushing hard on like, how far can we go without using the keyboard whatsoever? And so for like actual practical applications, we really like this idea of like bidirectional programming, where you can like edit the code and then also edit the output. But what if we just sort of put this limitation on ourselves where we're only allowed to like edit the output, and how far can we go? And so then, that's sort of like one kind of like outcome of the project, is that we really sort of investigated like what is the frontier, at least currently, of what sorts of objects we can create just with graphical edits. And then like Brian went on to do some like additional work for his thesis. I think it was called ManipoSynth, that sort of like applies this to like a sort of more general domain rather than just like HTML and SVG. And so that's one sort of like, line of work that was like coming out of the sort of Sketch and Sketch cinematic universe type stuff. But there's this other line of like, okay, how do we actually sort of work with kind of like in progress programs, like, as you're building up, maybe the sort of like fractal, or like as you're building up like any sort of program where generally it's going to be like incomplete. And so like, how do we handle those kinds of things? And so this is getting similar, maybe to the sort of like Hazel type territory. And so something that, I worked on a lot when I was an undergrad, also with Cyrus, he was a postdoc with Ravi at the time. This project is kind of like Hazel / Sketch and Sketch type project, was the idea of like, okay, let's say we have like one of these like work in progress programs. Maybe you're like writing some sort of like recursive function, like a map or a filter or like something like that. But it's like not done yet. And you want to be able to provide examples to the system and have it finish it for you. So this is the idea of like program synthesis. And so we were working on a project like that, where it's like, okay, now instead of having like a program and like an output, now we have program and examples, and we want to sort of like do something, to like bring those together in a similar way to like, maybe if you have a program and a new value and you want to get like some sort of updated program. And so there's all these sort of like forward and backward evaluation, like bidirectional stuff, related to like program synthesis, like creating like new programs to like, make these like SVG type objects. And yeah, I think that like a lot of that work was sort of just like exploring like, what is like possible to do in these sort of like, new kinds of settings. I'm not necessarily advocating that like everybody should like always just be using their mouse to like always do coding. But it was like really fascinating to see like, what can be done.
Okay. Yeah. So you were pushing the limits to see where the boundary was on doing that sort of thing, but also things with that bidirectional where you could go from the code to the mouse and back and forth. I think just from my own personal experience, because I worked with Visual Studio back whenever that, it wasn't just VS Code, it was like this full thing where on one side you would have your code and then on the other side you would have this visual representation of it. And where I worked, that was just included. Everybody had that product, had the license key. So it was available to me, but I found pretty quickly that I preferred to simply write the code, because what would happen is if I touched this visual editor, all the code that I'd worked so hard to create over here became really ugly, and like whatever it regenerated was just, it was just terrible. I mean, no offense. I mean, I think the concept is great, but just it didn't fit. Maybe I was a little OCD or something, but like I didn't like that. So I ended up not using the visual part at all. But yeah. So
yeah, absolutely. No. So I have a similar experience of like, using Dreamweaver. I don't know if you've like ever used that, but it's sort of like Adobe Dreamweaver. And like, maybe it's much better now. I haven't used it in like, I think over a decade. But it would just create the most monstrous HTML. Like you could like, create a beautiful like website, and it's like, oh, this is my header, this is my this. And then you look at the HTML and it's like div, like all the way down, like, just terrible. We didn't formally like evaluate this or like prove this in any sense, but like definitely a goal of like Sketch and Sketch was to like actually construct idiomatic programs. And, when you're given a program and you're given a new value, what's a sort of like minimal kind of edit that you can make to the program without like completely just, one way to do it would be, essentially just like throw away the program every single time and then like give you a completely new program that was totally unrelated to your previous program, but like, would produce the sort of like output that you have right now. So we opted for more this sort of like surgical type approach where, edits here, like in the sort of like output, can kind of like, propagate back to the input and then have, corresponding changes in the input to get like your sort of like new like input program. I think that it like works better. It's like a lot more involved. And, it definitely has like some limitations of like, you can't always do that. Whereas something, that's maybe a little bit less involved might be a little bit more generally applicable. But for when it does work, I thought it was pretty cool when it did work. But yeah, no, I totally share the exact same sort of like reservations of like code generation from these sort of visual tools as well.
Is there something particular about using a language like Elm to do this based on the fact that it's purely functional, managed effects, things like that, that made it easier than, say, a program where it could modify state in any way, anywhere, anytime?
Yeah, so I guess there's two ways of interpreting this question, which is maybe first, like, in implementing Sketch and Sketch, was it easier to use Elm? And the second way of interpreting it is, was supporting a language like Elm in Sketch and Sketch, like, easier versus like a language that could use state. I'll maybe speak to the latter one first, because I'm super excited about that, actually. So one of the, lovely, lovely things about a language like Elm is that it is, really simple. And I don't mean that like in a bad way. You compare it to like some other languages, maybe, it's sort of like canonically something like C++. And that language is just like very, very complex. And there's very, very good reasons why it's complex. And it supports like a lot of different things, and it's evolved over many, many years. So there's nothing wrong inherently with being complex. But if you do have a simple language like Elm, what that means is that the tooling can be, it's a lot easier to like write tooling for a language that's simpler. So, we only had like a PhD student and like an undergrad, we're sort of like scrappy team. And yet we could do some like really awesome sort of like program transformations. We could like write refactoring tools. We could do like, all these sorts of different things in a sort of like really manageable way that did not involve like a lot of like compiler hacking or like, all these sorts of things. And so the barrier to like writing sort of like language tooling was very, very low, I would say. That being said, it was also not really like a toy language where it's like, okay, this is just a really simple sort of like prototype language that like no one would ever actually use. Like Elm is like simple enough to like write, tooling for it. But on the other hand, it's not so simple that you can't actually build like a real system. Like proof in point, like we had like, I don't know, I don't want to quote the exact number because I don't remember off the top of my head, but I think it was like 20,000 plus lines for like Sketch and Sketch. And so, yeah, it was just this perfect balance of like, okay, manageable enough to like write tooling for it, but realistic enough that you could actually build stuff with it. And so, for projects that I've worked on, even now, like multiple years later, I've still, sort of targeted Elm for like this sort of like perfect like, blend between like I can use write tooling for it as like a single person, and also it would not be like completely useless. It's just sort of like, in the ether language that I just like made up. So yeah, from a researcher's perspective, it's like lovely from that regard.
Yeah, and I agree with that. Simplicity is not just for beginners. That for me, as someone who writes Elm code in production all day, we have over 100,000 lines of code. It's like my calm place, like where I can go and I know that I'm able to be productive, but I don't feel overwhelmed by all of the things that I have to think about. I can just jump right back in no matter when I last left it. So yeah, I totally agree with that. So then this kind of brings me to your more recent work. You mentioned the program synthesis with Sarah Chasins, and then you also did some research on how statically typed functional programmers write code. And this even mentions Elm in, I believe, in both the document as well as the video that you recorded for it about Elm's compiler as assistant. So do you want to expound on that a bit?
Yeah, absolutely. This was a really fun project, I thought. So, after working with Ravi for 4 years, I decided to go to grad school. And so now I'm working with Sarah Chasins at Berkeley. And, sort of going into grad school, I had this, idea that is like, okay, like I really, want to build tools for statically typed functional programmers. But in order to like build, tools that are going to like really meaningfully like improve the lives of like the developers like working with these languages, first I need to understand what are their existing processes. And, there's a lot of like folklore of like, how statically typed functional programmers write code. Maybe they do this or that. But like, I was like, okay, actually like, let's just sort of see if we can come up with some sort of like, at least somewhat comprehensive, like understanding of like, what are the sort of general strategies or processes that like statically typed functional programmers are employing just in their sort of like day-to-day practices. So that's what led me to do this project on how statically typed functional programmers write code. This was not just Elm. So I also looked at people who were working with like Haskell, OCaml, F#, these sorts of languages. But the sort of like general premise was that I had two main data sources for this project. One of them was where I had people come in working on programming tasks over Zoom, because this was like, really COVID era times. And the idea there was that, I could sort of give them particular kinds of tasks to work on that I think that would kind of explore sorts of like questions that I had, like as I was like watching them and sort of like analyzing, what they were doing, things would come up and they'd be like, oh, that's interesting. I want to probe deeper. And so I could sort of like, kind of in a more targeted way, kind of see what sorts of like processes they were working on. And then I also had like an interview with them afterwards, like ask them about like specific things that happened during the study. So that was kind of like, a little bit more of a controlled setting, I'd say. So to sort of like counterbalance that, I also looked on Twitch and YouTube, and I saw a bunch of people doing like live streams of coding, which was super cool. And so, I was looking at these videos and seeing like, gosh, this is like really similar to like my study protocol where they're here, they're talking about what they're writing code on. They're sort of just like doing it like kind of naturally, like, whatever they would sort of like want to work on sort of like out in the wild. And so like, I don't have a say of like what they get to work on, but it's sort of more like, ecologically valid is, maybe a word they would like throw around for something like that. So I sort of was like, looking at these two kinds of like sources of like people writing code, sort of like really closely looking, what are they doing like line by line, like what processes are they doing to sort of like build up the sort of like qualitative theory of some of these kinds of processes. So for example, I've been talking a little bit kind of abstract right here, but if we're going to dive into like maybe like, one of the like sort of details is like, there's this sort of like general like common wisdom of like, okay, you get your types right. And then once you have all of your types right, the rest of your program is just going to like flow from that, and everything's going to be like, perfect. You can like, run your code, and it's going to like be great. And that is true, like in some cases for sure. Like if you sit down and you think really hard and you get the right type, then the code kind of just writes itself, which is a lovely, lovely experience. But actually, in a lot of cases, what we found is that participants would like write a type signature or type definition, and then they would write some code and be like, oh, actually, this doesn't feel like super ergonomic, or like something feels weird about this. They would like think about the problem domain more. They would rewrite their type definition. They would like work on some code, and it was sort of like an iterative process where it wasn't like types first, program flows from it. So that was like kind of like interesting to see. Another one is like seeing, exactly like how these folks are like using their compiler like as an assistant, making an edit to like a type definition, and then seeing like all of the use cases of that type, pop up in the compiler error messages and sort of like treat it as a to-do list, or other sorts of like things like this. It was cool to see like, yeah, some of the folklore wisdom definitely held. Some of it, maybe was like a little bit different than like we had thought. But yeah, overall, it was a really like pleasant experience, I'd say.
Very cool. Okay. So yeah, this makes me want to dive in a little bit about what you're talking about here. So one of the things I could see where, yeah, when you're doing a live coding session, but you are watching it, you kind of have that like Schrodinger's cat problem where it's like while you're observing it, they may behave a bit differently than if they were doing it on their own. So yeah, that's great that you could find multiple sources for that. But then sort of bringing that to what came out of that, like what your findings were, I think this relates to how I love Elm. And like one of the reasons that it's so great is that when I'm working, I do this iterative process, like you mentioned, where it's really great with custom types because like, let's say I'm building like some way to view errors. And so I have this custom type with different types of errors, different variants. And so maybe I start with only one and then handle that case. And then I add the second case, even though I may have sketched out and sort of commented out other variants and I kind of know where I want to go, but instead of having a whole bunch of errors and have them like partially done, I'd rather take each variant, solve it to completion, and then move on to the next one. And it just, yeah, it's a very nice way I can, get these, I can make commits as I'm going along and see these logical connections between the types and the code that comes out of it. So yeah, I think that's it fits with my experience anyway. So.
Yeah, that's really cool to hear. Yeah, I have to say like one thing that I'm really happy about is that a lot of times when people like hear me talk about it, or like, even the reviewers for like the paper kind of felt like viscerally like, oh yeah, like that's what I like feel like when I'm writing code. And I feel like, really proud that, maybe, I'm actually like sort of, faithful in sort of describing how this group of people are like actually writing code. And, one sort of thing that's kind of like interesting is, totally did not tackle this at all, like in any of the stuff that I've like done. But it'd be like interesting to consider like, okay, once we have an understanding of how expert statically typed functional programmers write code, is there some way that we can actually use this to inform, maybe how we will like onboard people onto like learning a new language? So if you know that people, maybe do some sort of process like where they're commenting out different variants in the algebraic data type or the custom type, they're using their compiler as an assistant, maybe they're doing this iterative process, if we actually know like what these kinds of strategies are, like is that, maybe some way that we can begin to like inform, beginner sort of documentation or like, when people are like learning this sort of language. I don't have any like good answers there, but I think that it'd definitely be interesting to consider, actually this sort of like real practices and making that way into the sort of like more pedagogical type stuff. But again, that's not my area of expertise, so I can't say for sure that would help.
Yeah, but I think it starts to give us some understanding of where to start with that. So this makes me think about when I am teaching someone new to Elm how to use the compiler, because oftentimes they're coming from either an interpreted language like Python, or they're coming from a compiled language where the compiler errors in the type system aren't as helpful. And so particularly when, well, I guess in both cases, a lot of times folks will see that compiler error, and it's instead of going to that compiler error and reading it and then trying to use it as a directive, if you will, they instead would see that error and then go back to the code and like try to figure out on their own without using the compiler error message, or make a lot of changes and then try and fix a whole bunch of unrelated compiler errors. So I think that there's work that I think could make the experience of programming much nicer in these environments if there's that process of learning and teaching those ways of using it up front versus struggling a whole bunch with like, oh, the compiler's yelling at me, when really it's like, no, the compiler is your friend, right? The compiler is your assistant. It just wants to help you. It's
yeah.
But it takes using it in a particular way of like, not, and I know this is in some of your research, of like not expecting the compiler to succeed when you run the compiler. It's more of, I want the compiler to provide an error, produce an error or multiple errors, and then I can go through those and sort of fix those errors one by one. And then when it no longer compiles, I'm good.
Yeah, absolutely. And I think that, nowadays, so I've pivoted like a little bit in the sort of like research that I'm doing, and that I'm working more with people who do not have like a lot of background in programming. So they don't have, familiarity with like statically typed functional programmers, which maybe we can talk about if we have time. But the point that I wanted to like mention is that like a lot of times like novices, when they get an error, they're actually like very scared, and they feel a sort of like sense of shame, and they're like, oh no, I've done something wrong. Like, I'm not a good programmer, like, these sorts of like feelings. And it's like quite different, from like how you're describing it, or like, from how the participants in the study, where they're like actively seeking out like a sort of like error message from the compiler. And so, one of the sort of things that like I'm really interested in is like, okay, how can we build programming systems that are going to be, less intimidating for folks, that are like meeting them where they're at. And I think that, Elm is like, a fantastic example of doing that for certain like classes of people. I think that, there's, lots of work to be done in sort of like building programming systems that meet people where they're at and can kind of like empower them to do the kinds of computational tasks that they want to do in a way that, makes sense to them. So that's like, what I'm really, really excited about. And, I love to see projects that, make people feel delightful, when they're writing code, instead of intimidated or scared or like ashamed. So yeah, I think that that's like, one really lovely aspect of Elm that seems to like click for a lot of people, certainly for me. And I have to say as well, something that I should have like mentioned earlier is that like also the Elm community, in addition to the language itself, has been incredibly welcoming, incredibly kind to me. Very excited to be like participating in my study. Like I've gotten lots of good feedback. And so I definitely like have a huge shout out to like the Elm community. I've always felt like, it's a really, really lovely home for the language. So I think that like, both the language and the community definitely can make an impact in those sorts of things.
Yeah. I'm so glad that you brought up the term or the phrase meeting people where they are. Because I was actually, the first episode of this series of teaching and learning Elm was with Ryan Haskell. And that was one of the ways that I described how he writes his documentation and thinks about it from the perspective of, if someone is coming from a framework like React and Vue, like they have a certain set of words that they use. And so instead of being pedantic about it, Ryan is able to take the words that people already use and create the tutorials and guides from that. So yeah, I think that's a really great way of looking at it. And to this idea of like, yeah, the shame of errors, I don't think this only applies to novices. I think it applies to anyone who has used a compiler in other systems, like, like Java and C#. Like I had a history of doing that, and I found like I would avoid the compiler error messages, maybe a sense of shame, but also just a sense of like, it's just a distraction. Like it prevents me from flowing through the code versus like with Elm, where the compiler is actually helping move it forward instead of being a blocker. So this actually ties into another question from Parker Ziegler here. This is more of a general question or line of questions about Elm and how it applies to developers, web developers in particular. So, quote, from your perspective, what elements of Elm's language design and tooling make it especially ergonomic for web developers, particularly with so many other options out there? By the same token, what elements do you think inhibit Elm's adoption at a larger scale? End quote.
That's another really great question. Yeah, so I'll say one thing before I maybe dive into that question specifically is that I really believe in, a sort of plurality of tools. So, I'm really excited by the fact that there is Elm and there are competitors to Elm. There is React, there is Vue, there's all these different things. There's never going to be, or at least I don't want there to be one language to like rule them all. And I think that, different folks really like different things. And, if you really don't like Elm, like that's okay. So, I think that, yeah, that's definitely like my perspective on things. I think that we should be encouraging like more tools and more ways of like looking at the problems rather than fewer. But that being said, I also do love Elm. So, yeah, maybe this is not specific to like web development, just like not having to reason about like complex control flow, just like knowing exactly like, what sort of things are going to be executed. I don't need to worry about exceptions. I don't need to worry about like managing like all these different like effects. It's sort of like just an amazing sort of just like tailored experience to just like writing the thing that you like care about, like when you're doing like a web app. If you're doing like something, I don't know, maybe super low level and you like really care about like, particular performance and like certain things like happening like, maybe at certain times or something like that, then, maybe the sort of like managed effect system that like Elm provides is like not going to be the right fit. But, if you're just trying to get like an interactive like web app going, I think it's just like, yeah, you can focus on the things that you care about and just leave the sort of like runtime and like the effect system and all of that to the computer. I think that sort of like, burden of not having to like worry about like, state or like, handling, different things like that is like definitely like one really nice aspect of it. By the same token though, it's definitely a limitation. So one, I don't know if it's a secret, but it's like maybe a secret about Sketch and Sketch is that actually it uses a forked version of the Elm compiler. So let's see, I don't want to like misspeak here, but I think that, so it's using Elm 18. We haven't worked on it in a while because there was some sort of like use of like native code, and there was like some like modification that we did where there was like some deadline and we really needed to essentially have something like an exception, but we didn't want to like rewrite things. So like somebody on our team basically made this sort of like backdoor where we could kind of have like exceptions in Elm, and it's used in like this weird spot, and it's just like nobody really wants to like look at that part of the code base, but it is like technically there. And so there's definitely something to be said for like, okay, sometimes you kind of have to have these backdoors, and there's definitely that sort of like limitation of like, okay, if you don't want to take the time and like do it right, then that can definitely be limiting to like be in that sort of managed environment. But that being said, like, I'm not sure how much of a downside like I view that, because like, if we were to do this like again, I don't think that I would like recommend like doing that. I don't think that it was like maybe the best engineering trade-off like at that exact time. Or maybe for that exact time, when we were like on a short deadline, it was okay. So there is always the sort of like idea of like, okay, you get a lot of benefits, you can, write tooling easier. You don't have to have like so much like overhead of like thinking about like mutation, exceptions, all these other things. But it's like, sometimes you just want to write an exception, and like, yeah, I feel that. I also work a lot with like OCaml, and I really don't like that it has mutable variables until like I kind of just want to write a mutable variable. And I'm like, I want to write a mutable variable, but I don't want to have to like read code that uses mutable variables, right? Like I don't want to use like a library that has like mutation or is like doing anything like that. But like, I want to do that. And so like, I kind of say that like in jest, but also it's kind of true. There's definitely like pros and cons. And yeah, I would say that like, yeah, just being aware of like, the benefits that the restraint and the language can give you, and also the drawbacks, is definitely something to think about. But yeah, I'm working on a project right now, or I'll soon be working on a project that's going to be like essentially sort of like front end for like a programming tool. It's going to be like a web app. And even all these years later, I'm still totally going to write it in Elm. So yeah, I think the trade-offs are worth it.
Your preface here about it's great that there are different types of tools out there. I totally agree with that sentiment. Of course, I'm a huge fan of Elm, but I think that by seeing different perspectives, we can see, what are the trade-offs, and like why are they worth it for me, but they might not be for someone else, and that's okay. It's all right.
Yeah.
But yeah, and I knew that it was a fork of the Elm compiler, but I didn't know the details of why. So yeah, I'm kind of curious, like if there weren't that time constraint, like how else would that have been done? Like could it have used ports, or what other options could be available for that? But and maybe maybe the answer is just that's the only way, or I don't know, but that might be curious to, if someone out there is interested in this, might, seek to find. I don't know is that open source? That is, right?
Yep. It's all open source.
Okay.
So people can totally look at all the like dirty hacks. Yeah, so I'm trying to remember the exact details because this was like a number of years ago, so I might be like not getting all of the details perfect. But I think, let's see. So originally, I think the original reason that we had a fork is that there was this really obscure, like niche edge case of like pattern matching where it actually was taking like exponentially long to compile the program in the number of branches that you had in your case expression, which was like really weird. And I don't really remember the details. But I think that was like the original reason that we had like some sort of fork. And so I think that like Brian, like, fixed that. And then we were just like using that for, I don't know, we had like some big pattern matching like in the code. It's probably fixed by now. This was like maybe even like Elm 17 at this point. That was like one reason where we had a fork, which is kind of just like a minor reason. But the reason that I was talking about before with like the exception handling, I think that basically there was a situation where we were like deeply like nested in some like pure code. And it was possible that it could like fail, or like we needed some value kind of like way higher, like up the stack. And so like what would have been involved, I'm guessing, this is just, again, sort of like, very hazy like recollections, is it would be like refactoring all of the intermediate code to use like an either or like a result type, where it could be like this, or it was like a failure, or it was like, two different things. And it was like quite nested, and we were like quite short on time. So I think that basically just sort of like hopping up the stack and like going to here and then like getting the value that we needed was kind of like the decision that was made. I was not like involved in like that, so I don't remember exactly like what the trade-offs were, but I think that it would have been a matter of, like refactoring the types, these sort of like intermediate type signatures. As a side note, one sort of like really interesting area of like, programming languages research is this idea of like an effect system. I'm not sure if you've like come across it, but the idea is that it's kind of like checked exceptions in Java, but like way more ergonomic, where you can kind of like sort of annotate, the different kinds of effects that a function might have, like, maybe failability, sort of like, or possibly like returning an error, or like using mutation, or like being able to print out to like the console or something like that. These are all different effects. And so you could sort of like annotate like all of your functions. And, if you trade the sort of like changing the type signature for like adding an effect, you've essentially like not really gotten anything. Like you still would have to like add all of these like intermediate effects, like all up the stack. But one thing that's like really cool is that people are looking into effect inference. So now all of a sudden, if you don't have to actually annotate every single sort of intermediate function, but you still have it like checked statically. Like if you need to make sure that something is pure, you can check that and like inference will like ensure all the way down the stack that you never need to do that, then that would sort of like remove a sort of like large amount of like annotation burden. So that's not an area that I'm working on personally, but I think it's super cool because it sort of gets around this sort of thing of like, what do you do when you have like all of this intermediate code that you don't want to modify, but you have control of the sort of like top and you have control of the bottom, and you want to kind of like, transfer information between the two. So then you get into things like effect polymorphism, which is kind of like type polymorphism, but for effects, and like all these sorts of things to make it like more ergonomic for that kind of situation. But we didn't have that, we don't have that for Elm. It's definitely like bleeding edge programming language research. So I think that the change would have been essentially change all of these functions in between.
I gotcha. Yeah, if there were some tooling that could automatically do that, that would be amazing.
Yeah. That would be awesome. Yeah.
Okay. So I guess then kind of moving on to what you're up to now, you have this, from this year, this PLDI paper, refactoring programs via component-based synthesis using canonicalization-based equivalence checking with Sarah Chasins. Want to talk a little bit about that? It was recently Thanksgiving. We're recording this in early December. So, talking about Cobbler, I feel like might be...
Yes, the tool is called Cobbler. So I was working with some undergrads on the project, and one of them, Jacob Yim, who's now a PhD student at UCSD, came up with the name Cobbler, which I really liked because I feel like it cobbles things together and like it's like a pie, which is like really cute. So the tool is called Cobbler. It's again sort of like a research prototype, but it does work on essentially like an Elm like language. It actually uses Elm format under the hood, which was like super awesome that I could like reuse that tooling. The idea is like if you have some code that is like written using something like direct recursion or sort of like pattern matching, but you want to refactor it to use like a library, for example, the Elm standard library where you have like map and filter. Normally you would have to sort of like manually do that rewrite. And so, one of the participants, or actually, sorry, a number of the participants that I was like talking to essentially expressed that sometimes it's easier to just, pattern match on your data and then just like bang, 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 like handle each case sort of independently. And then you have your function and it works. But actually they would prefer for like readability to have like a nice pipeline where you have like the pipeline operator. It's like, take the data, then do some like result combinator and then do like a list.map and then like do something like that. But it can be like a lot harder for them to figure out like, okay, exactly what combinators do I need like at each stage versus something like a pattern match where it's just super clear. Like, okay, I have a nothing. What do I do? I have a just, like, what do I do? So this tool uses program synthesis, which is essentially the computer like generating code for you to give you like given this sort of implementation of the code where it's using the pattern matching and the direct recursion, it'll give you an equivalent piece of code that uses this sort of library components, sort of any library that you want. I sort of just use the Elm standard library for like an example, and it'll refactor the code to use those combinators instead. It's not perfect. It doesn't always work because of a variety of like, technical and theoretical reasons. But it can work with things like, map and filter and all these sorts of like combinators like that.
I guess this is a project that you recently finished. Is there anything else that you wanted to talk about before we move on to picks?
So I guess this will maybe relate a little bit to the pick that I have in mind. But I mentioned before, that I'm not working directly with statically typed functional programmers now. I've sort of like pivoted a little bit to working more with people who don't have a lot of experience, like, writing code. And in particular, I've gotten really interested with people who come from sort of like non-traditional computer science background, in particular, a group of folks like biologists, who are producing like a lot of data, like in the wet lab, doing a lot of really cool, awesome biological experiments, but don't usually have the sort of computational background to do like all the kinds of analysis they want. And so it's been a blast to be like learning a lot about what their sort of like computational needs are, how they think about problems and, what kinds of programs they need. And, in what ways existing programming languages are sort of serving them and in what ways they're not. I would just really encourage anyone who is, really looking for some like really interesting, fun and sort of like impactful sort of like work to look, beyond people who we might traditionally consider like programmers or like software engineers, because lots of people need programming. And there's this sort of like a lot of really cool work to be done in, what would a programming system look like if we designed it, with biologists for their needs sort of thing, rather than, sort of just saying, okay, this is the system you have to use. That's just kind of how it goes. So yeah, I don't really know, exactly what that's going to look like right now, sort of like right in the middle of that. But I think it's like a really exciting area. And, I think that Elm has done this, a lot to like a large extent with like lots of different people. It's like, what would it look like if we did functional programming, for the web? Sort of like bringing these different kinds of ideas to different kinds of audiences. And I think that's just like a really, really exciting kind of area. So that's what I'm working on right now. And I definitely would encourage other folks to think about kinds of problems like that.
Cool. Yeah. Well, I'm excited to find what comes out of that. And also, it sounds like you're thinking a lot about programming for folks who, are novice and not necessarily already knowing how to write either, statically typed functional languages or, just beginners. And so, that sounds really neat. So what kind of biology experiments are these?
Yeah, so, there's like a whole world out there, and I'm definitely, just beginning to like learn like a lot of these sorts of things. But like I've been working really closely with a lab at UC Berkeley, and the kinds of things that they're really interested in is essentially called epigenetics, which is the idea of like, okay, we have our genome, and that's going to sort of like dictate, what kinds of like genes are like expressible by our body, like in the different kinds of like genes that we have for the proteins. But our eyes, for example, are producing different proteins than our liver cells or like other parts of our body. And the way that gets controlled is not necessarily like the DNA itself, but sort of like attachments to the DNA that can kind of like regulate like, okay, I want to turn this gene on now, or I don't want to turn this gene on right now. And that can be regulated by like environmental factors or like, heritable factors or these other sorts of things. So it's really about like the sort of like control of like what kinds of genes are getting expressed at like different points. And they're really interested in studying, how that works basically in humans. Can we like modify, the sort of like epigenome of humans? Can we, do different like kinds of experiments like that? And yeah, essentially it involves a lot of like, dealing with like physical objects, which I'm not used to. I'm used to like working with a computer, but there's like, pipettes and like tubes, and they're like mixing things, and they're growing cells, and they're like, doing different treatments to the cells, and those sorts of like experiments. But yeah, biology is like a super, super like vast world. And yeah, definitely really excited to learn more about it.
Very cool. Okay. Well, you mentioned a pick that you had. You want to move on and say what that is?
Yes. So I have a book recommendation that I'm currently working through right now that's related to this idea of designing with the people that you're designing for. It is called Design at Work, Cooperative Design of Computer Systems. It is a really awesome book. It's like a whole collection of people who have thought, really seriously about this idea of like, okay, what does it mean to do participatory design where, our sort of participants are actually going to be actively involved in the design process. And yeah, it's not exactly clear yet what that looks like for like programming languages in particular. But, this can be applied, more broadly for computer systems, whether that's just like people who are, entering data like into a computer or like using other sorts of like applications that are not necessarily like programming based. There's this enormously sort of like rich literature on like how we can involve the users in the design process that I'm also still learning about and really excited to be learning about. So yeah, that would be Design at Work, Cooperative Design of Computer Systems.
All right. Yeah, that sounds interesting. That's something that I might like. So yeah, I have one pick as well. And it's again, kind of, picks for the people that I am interviewing. And so kind of, you mentioned biology. I knew that you were starting work in that. And so I've started reading this book called Entangled Life by Merlin Sheldrake. And it's about fungi and mycelium and mushrooms and molds and all these really interesting ways that surround fungi and like how they interact with the world and how they interact with us even. If you are interested in how systems work and just maybe thinking differently about what it means to think, like what, because we have such a history of thinking of like this, CPU or brain-based thought, but the way that mycelium work and these, like they have this experiment that I think it really makes it interesting to think about is how mold can recreate the railway network of Tokyo by placing different food in different places. And so it finds the shortest path. And so it really takes a different set of assumptions, or requires you to maybe rethink your assumptions and how you think about thinking. So that's my pick. Entangled Life.
That sounds super cool.
Yeah.
I think I've heard of that Tokyo experiment before, but I didn't really know anything about it. So that sounds really fascinating.
Yeah, that's just one little bit of it. I mean, it goes a bunch of different directions, but I'm only like halfway through it right now, but I will recommend at least the first half. I don't know where it goes from here.
Okay, I'll only hold you responsible for the first half.
Yeah, thank you. But did you have anything else?
Nope, I think that's it. Thank you again so much. This was a really lovely conversation. I really appreciate, how thoughtful you've been and all the questions and the preparations. Thank you so much for having me.
Yeah, thanks, Justin. Folks out there who are interested and enjoy this show, please rate and share, and I'll put show notes for everything we've been talking about. So, yeah. Thanks, Justin. Have a good one.
You too.